Hi, I'm Jeff Cogswell, and today I want to explore some of the fundamentals of parallel programming with Silk Plus. Now, many things that work in serial programming can break in parallel programming, resulting in bugs. So let's try out a couple things here and see how it works in serial programming, and then compare how it works in parallel programming and see if we do indeed have some problems. I've got some code here. I've got an array that I'm creating, and I'm setting the size based on the command line options. That way I can try out this test with different array sizes. The next thing I'm doing is I'm completely filling that array with all zeros. Now I'm going to loop through that array, and I'm going to fill it with a random number. Now, a couple points here. If you've been reading my blog, you know that the rand function here is not thread safe. And we're going to look at that in a future video, exactly what's going on here, but we're going to go ahead and use it anyway in this time. And as I loop through this array, I'm incrementing this variable shared. Now, I could just say array I equal whatever I'm putting into it. But what I want to demonstrate here is what happens when you have a parallel loop and they're trying to share a variable. The serial version is going to work just fine. So here we have shared plus plus, I'm incrementing it, and I'm pushing the random number into the array. Then I'm going to loop through the array a second time, and I'm going to look for spots where the array is still 0. And what that means is either the random number we got back was 0, or more likely that element got skipped. How did that element get skipped? Well, if two iterations of the loop simultaneously increment shared, then one of those items in the array is going to get skipped. So during the serial version, it's not going to be a problem because that's never going to happen simultaneously. So let's go ahead and build this and try it in the serial version. I've got a quick little script here that's going to build it, and then I'm going to copy it up to my Amazon server where I have 32 cores running. Now I'm going to come over here. This is my Amazon server, and I'm going to run it, and I'm going to put in a big number here, 1,000,000, and there were no collisions, which we expected. Now let's come back here and change this to a Silk for loop. I'm going to rebuild it and copy it up. And run it again. This time we had 30,000 collisions. In other words, 30,000 times the variable shared got incremented simultaneously by 2 of these, and what that means is 30,000 elements of the array actually got skipped, and that's not a good situation, obviously. Now what's interesting is if we lower this number significantly, we didn't get any collisions. Put it at 1,000, still no collisions. 10,000, still no collisions. 100,000, still none. When we get up to 1,000,000, then we're seeing some collisions. The reason is, with smaller numbers, the system, the Silk Plus runtime, isn't having to process as many threads and as much information, and it actually manages to keep up. Now the problem is, if a programmer is just starting out and is new to this type of programming, they may only test with a small number of cores, a small number of loops, small numbers of array sizes and whatnot, and the result is they may think that the program passed the tests. They may think their code is fine, and they ship it and deliver it, and then the client, who is using much larger numbers in a larger number of cores, has all sorts of crashes and bugs, and the young developer can't figure out why. So that's why we need to fully understand what we're doing with parallel programming.